Hi, so we've been learning about we've been learning about ionic compounds. Ionic compounds formed by the transfer of electrons from metals to non-metals, positive ions to negative ions. And so far you've been learning that it's such a simple job that you have positive 1, positive 2, positive 3, and then negative 1, negative 2, negative 3, and it's easy going. But life is always not so simple. So we need to talk about polyatomic ions. Polyatomic ions are the combination of two metals sometimes, which have a charge on it. And there is no way to figure out that one carbon is going to compound with, going to bond with three oxygens and with a negative 2 charge, which is not something you can get from the periodic table. You have to memorize it. So the reason I call it a polyatomic ion because it is more than one atom and it has a charge. As long as anything has a charge on it, it is called ion, because atom is something that is neutral. Atom is neutral. So if something has a charge, it's not an atom or molecule. It got to be ion. And polyatomic ions mean multiple atoms with charges on them. Okay, and we have to memorize it. As I'm saying, the fact about this is that this is not the information you can get from the periodic table. It doesn't help. You have to just know them. Okay, so you need to memorize the polyatomic ions provided on the table that I can provide in the class, or you can write it like right now. There is a polyatomic ion like sulfur combines with oxygen. So sulfur can combine with oxygen, SO4 minus 2 charge. So the formula is sulfate. Okay, SO3, and the formula is sulfite. Then PO4 minus 3, phosphate. And then PO3 minus 3 is phosphite. Okay, then NO3. So you cannot just say that, okay, if you have 4 oxygens, it's 8. Okay, and if it is 3 oxygens, it's 8, because it's good for sulfate and phosphate, but with nitrogen, even with 3 oxygens, it's 8. So it's nitrate. And then with 2 oxygens, it's nitrite. So yes, I can say that if it is more number of oxygens, it's 8, and less number of oxygens, it's 8. Then you have CO3 minus 2, that is carbonate. Okay, so you have to see that when the polyatomic ions comes, the name is ending with 8 or 8. Okay, so I want you to look at the difference. If phosphorus is alone by itself from the periodic table, the name for the phosphorus will be phosphide. But if phosphorus is attached to oxygen, it will become phosphate. And as I said, more oxygens is 8, and less oxygen it is 8. So phosphate or phosphide. But this is the difference, that 8 or 8 means it is attached to oxygen. Okay, oxygen is involved, and 8 means it is the monatomic ion. Monoatomic ion means ion of only one atom, and these are called polyatomic ions because they have more than one atoms on them. So the list is not over yet. So we have hydroxide, OH minus 1. So yes, it has oxygen, but it is still ending with ide. So this is again one of the exceptions of 8s and ides. So you have to memorize all of these. And then there is acetate, C2H3O2 minus 1. That is called acetate. And then there is only one cation, one positive ion, and that's called ammonium. So you have to memorize all of the polyatomic ions that I listed here. There are much more than these, but these are the minimum you have to know. Okay, these are the minimum. I cannot make the list any shorter than this. You have to know that sulfite is SO3 minus 2. You have to know it with the charge. And you need to know that sulfate is SO4 minus 2. And phosphite is PO3 minus 3, and phosphate is PO4 minus 3. So you have to know the charges, you have to know the formula, you have to know this subscript and the superscript and the eights and the ites. So you have to, whatever it takes, it has to be memorized. And it has to be memorized soon, because as we move further on, we will be using them all the time. And if it's not a matter of just this unit or this one quiz or one test, we will be using it all through the year. And if you don't memorize it, you will be losing points all through the year. So as far as you memorize the polyatomic ions, the rest of the story is not a big deal. Okay, the polyatomic ions could be cations, anions, but there's only one cation. Most of them are anions. Okay, so most of them are anions. Then you have to keep the name as is. So as I said, the rest of the story doesn't change. So if when you look at it, you should know that I just told you that NH4 is ammonium. You know, this is NH4, positive 1. So when you look at this formula, you know, you will say, okay, I know NH4 is ammonium. So the name will be ammonium. Okay, and this is sulfur by itself, and it changes into sulfide. Why would it change into sulfide? Because it is the second one, it is the anion, because NH4 is positive 1 and sulfur, if you go to the periodic table, is negative 2. So what will be the formula? The 2 goes to ammonium and 1 comes to sulfur. Well, when the 2 comes to ammonium, there is already a 4 here, so I need to keep it in mind. That's why I'm going to put this whole thing in parentheses and put the 2 around it. So I'm going to put this in parentheses and bring the 2 outside here. Okay, so the formula will be NH4, okay, parentheses, and then comes the 2 that is coming from sulfur, and then 1 goes to sulfur, and I don't write 1. So this is ammonium sulfide. So since sulfur is a negative ion, it will end with IDE. Okay, Mg is magnesium, and I just told you that the metals don't change their name. So magnesium, and then this is, again, you have to know that SO4 is sulfate. You have to memorize it. So you have already, if you have already memorized it, you know that SO4 is sulfate. So magnesium sulfate. Okay, then calcium, and what is OH? If you know, it is hydroxide. So this is how you do the naming or writing formulas with polyatomic ions. So ammonium, you have to memorize it, that ammonium is NH4 plus 1. Periodic table does not help you for this part, but yes, periodic table can help you for oxygen. So you go to the periodic table and you find out that oxygen is minus 2. So what should be the formula? The 2 goes to ammonium and 1 comes to oxygen. So when 2 goes to ammonium, there's already a 4 for the hydrogen. So I'm going to put this in parentheses and put the 2 outside, and 1 goes to oxygen, and I don't write 1. Okay, now I go to the periodic table and I look the charge for aluminum. Aluminum is plus 3. And nitrate, I have to memorize that the nitrate is minus 1. So when I write the formula, the 1 goes to aluminum and 3 goes to nitrate. Now I already have the 3 there, you know, NO3. This 3 is part of the nitrate. I can never change this number because it's part of the charge. So the 3 that I'm bringing around it, I have to put this in parentheses and put the number around it. So that makes it aluminum and then nitrate. You have to memorize that nitrate is NO3 minus 1. Now the calcium is plus 2 and carbonate, CO3 minus 2. Same rule, that if the charges are the same, they cancel each other, and I can write the ions. Again, keep it in mind that these numbers that are attached to the ions, you will never ever change them. So if SO4 minus 2 is sulfate, this number will never change or replace. It is only this charge that we play with. We are only exchanging the oxidation numbers. We never change the number that is part of the ion. So SO3 will stay, you know, this 3 will always stay with it. Calcium is, okay, I did that already. So you need to practice on the packet of polyatomic ions. Again, you keep it in mind that the biggest task in this unit is memorizing the polyatomic ions. The rest of it is just the process, and that is not too hard. So the polyatomic ions have to be memorized. All of these polyatomic ions have to be memorized by next class, no matter what it takes. You want to make flashcards, you want to write each one of them 100 times, it doesn't matter to me. But they have to be memorized before I see you next time. Okay, so that was polyatomic ions. We are still working on ionic compounds. Keep that in mind. We are still working on ionic compounds. And what are the ionic compounds? The compounds formed between metals and non-metals. Okay, metals lose electrons, non-metals gain electrons. So we just learned about polyatomic ions, and now I gave you very distinct charges of periodic table. I said everybody in group 1 as positive 1, and then we went 30. Okay, let me write it on a different page. Let me write it on a different page. Here is the periodic table. All right. Group 1, 2, and then we have 3 to 12. Then we have 13, 14, 15, 16, 17, and 18. So tell me how many valence electrons we have. We have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. This is how many valence electrons we have. So based on the valence electrons, we talked about octet rule. I know it's a repetition. So we are going to gain electrons. So we have -1, -2, -3. +1, +2, +3. And they vary in their charges. We have never talked about what happens in between here. The reason we never said that there's a specific 1, 2, 3 or -1, 2, 3 because they change. Okay, they vary in their charges. Sometimes they have 2, sometimes they have 3, but these transition metals, mostly they are +2. Okay, usually transition metals. So the reason I cannot specifically say plus, I mean, of course they're metals, so they're going to be all positive, no question about that. And usually they're +2, but there is a possibility that it is +2, +1, +3, +4. It is going to vary in their charges because they have d orbitals, and because of the d orbitals, the electrons kind of you know what you float, I should say. The electrons float from D to S, S to D. So sometimes they lose 1, sometimes they lose 2. And because of that, they vary in their charges. Again, if you still don't get what I'm saying, that iron, who is sitting somewhere here on the periodic table, iron could be +1, okay? And iron could be +2, all right? So when iron is +1, if you know that the name of the iron is ferrum, okay, so it could be ferrum or it could be ferric. So the higher the positive charge is, it ends with ic, and lower the positive charges, it ends with us, ferrous, not ferrum. Ferrum is the name of the iron. But instead of that, we can also say iron, and I use Roman numerals, iron 1, or I say iron 2, because it has a charge of 2. Same thing, I have copper. Copper could be 1, copper could be 2. So I can say, if I just say copper, I don't know which copper it is because it could be 1, it could be 2. So I have to specify it, that it is copper 1 or it is copper 2. Okay. So if I want you to write the formula of copper oxide, you are like, Ms. Kumar, I know that oxygen is sitting here. So I know that the charge of oxygen is -2, but copper is sitting here. And whoever is sitting in this area of the periodic table, they have multiple charges. So which copper do you want me to use? Because copper could be 1, copper could be 2. So that means my question is not complete. I must tell you that I want the formula of copper 1. So when I say copper 1, now you know that copper, the charge of copper is 1, oxygen is -2. So we crisscross it, you get Cu2O. What if it was copper 2? Okay, oxygen doesn't change, oxygen is here, so oxygen is -2. So if copper is 2, then the formula is going to be CuO. So you understand that copper could be 1 or copper could be 2. So this is the formula of copper 1 oxide. Because if I have to name it, I need to know that this is copper, okay, and then there is 1. So that means this 1 is coming from copper because this 2 is coming from oxygen. So it is copper 1 oxide. If you just say copper oxide, it will be a wrong answer. And here you don't see any number, so you have to find out what is the charge of the anion. The oxygen is -2, so copper must be +2. That's why there is no charge at the bottom. So you will say, okay, the name for this one is copper 2 oxide. So when you name them, you have to write their charges. Like if I have iron 2 sulfate, okay, so how would you write the formula? This 2 is telling you that the charge for the iron is +2. You don't have to go to the periodic table. It's written right here. So the charge for the iron is +2. And sulfate, you have memorized it, SO4 -2. So the formula is going to be FeSO4. What if you were not given the name and you are given the formula? So now you have to write the name. So if you have to write the name, you will say, all right, I don't know what is the charge of iron here, but I know that sulfate is always -2. And iron must be +2. That's why I don't see any number, because this 4 is part of the sulfate. It is not coming from iron. You know that the sulfate is SO4 -2. So this 4 belongs to sulfate. So the charge for the iron here must be 2. So when you write the formula, you will say it is iron 2 sulfate. If you don't write the 2 here, the Roman numeral, this is called the Roman numeral. We use Roman numeral to represent the charges. If you don't write the Roman numeral and you just say iron sulfate, it will be a wrong answer. So Roman numerals are used when cations have multiple oxidation states. Okay, so iron 2 or iron 3. So I have to write iron 2 or iron 3. Lead 2 or lead 4. So I have to use Roman numerals. Sodium does not change. It's always +1. So I don't write Roman numeral for sodium. So again, so let's do some more practice. 3 here. So this 3 is telling you that the iron is +3. I don't have to go to the periodic table. This 3 is always giving you the charge for the metal. So it is telling you it's only one ion. So chlorine is -1. So the formula will be 1 goes to iron and 3 goes to chlorine. So the formula would be FeCl3. Now scandium. Scandium is a transition metal, but scandium is always +2. Okay, that's why you don't see the Roman numeral here. Although scandium is a transition metal, but the charge is always +2. And oxygen is always -2, so the formula will be SCO. Strontium belongs to group 2. Okay, where did I do that? Strontium belongs to group 2. Strontium is right here. So strontium belongs to group 2. Let's do that. Strontium is +2, chlorine is -1, so the formula is going to be SrCl2. Now this 2 is telling you that the lead is +2, oxygen is always -2, so the formula is TbO. This 2 is telling you that cobalt is +2, sulfur is -2, so the formula is COS. Now 1, copper is +1, fluoride is -1, so the formula is CuF. So these Roman numerals give you the oxidation number for the metal, for the transition metal. This is not for all of them. It is only and only for transition metals. So let's do some practice on naming the transition metals. So when you are naming the transition metals, tin is also a transition metal. So you have to know, because tin could be 2, tin could be 4. Okay, So I need to know what is the charge of the tin right here. So this 4 must be coming from tin. So I will say tin 4 phosphide. Okay. Then calcium is in group 2. Calcium is not a transition metal. So I am not going to use a Roman numeral for calcium. I'll just say calcium fluoride. Okay. Zinc is a transition metal, but zinc is always positive too. So I don't need a Roman numeral for zinc. So I'll say zinc sulfide. Gold is a transition metal. So I will say gold 3 chloride. So if I need a Roman numeral and I don't write it, I will be wrong. And if I don't need it and I write it, it will be wrong. So nickel, there is no number that I can push back. That means I need to know what is the charge for oxygen. Oxygen is always -2, so nickel must be +2. So I will say nickel 2 oxide. But barium is in group 2, so barium doesn't need a Roman numeral. So barium bromide. So we just need a lot of practice on this to see that when to use Roman numerals, which is the transition metals, how to name them, and how to write formulas with them. So in this video, we talked about all of the ionic compounds, whether they were binary compounds, whether they were polyatomic ions, whether they were transition metals. So this is the end of ionic compounds that are formed by the transfer of electrons from metals to non-metals. All right, everybody. Thank you.